So in the first video for 6.2, what we're going to be doing is finding something called the inverse of either a function or a relation. So we've learned about functions. Relations are similar. They're just kind of how x values relate to y values. So the definition of inverses, we're going to write that right under this first bullet point here. An inverse relation is a set of ordered pairs obtained by exchanging the coordinates of each ordered pair. Okay, so exchanging the coordinates of each ordered pair, what that means is that the x values trade with the y values. So what used to be the domain becomes the range, what used to be the range becomes the domain. So we've got these ordered pairs right here. It says they're the coordinates of the vertices of a rectangle. Find the inverse of this relation. Okay, so the inverse, we are literally just going to take the ordered pairs and we're going to swap them all. So instead of 1, 3, we're going to swap them and they're going to become 3, 1. And the second ordered pair is going to do the exact same thing. Swap the 3 and the 6. Swap the 0 and 6. Swap the 0 and 1. So that's literally what we did, is we exchanged the coordinates of each ordered pair. We formed an inverse. So what we're going to do is plot them really quickly. So it says these form the coordinates of the vertices of a rectangle. So we're going to plot those, and then we're going to plot the inverse just to show how they relate to each other. So 1, 3 is right here. We've got 6, 3. It's right here. 6, 0, and 1, 0. So this was the original rectangle that those 4 points plotted. So normally you don't connect the dots. Normally a set of ordered pairs is just a set of ordered pairs. But let's see what this new one looks like, the inverse. So if we have 3, 1, that would be right here. 3, 6 would be up here. 0, 6, and 0, 1. Okay, so that makes this rectangle right here. So it's really similar to this rectangle. It just kind of got rotated kind of 90 degrees to the left like that. So that's what the graphs will look like, and we'll learn more about that on the next page. All right, so this is an example if you just have ordered pairs. We could also deal with functions. So some properties that we can write down right here, and this is basically what we had on the previous page. If f of a equals b, meaning if you have the original function, you plug in a, you get b, then we can write the following. So here's our notation for inverse. We write f with a little -1 like that. So it's not an exponent. That right there stands for the inverse. So whenever you see this little -1, that means we're talking about an inverse function. So since all of the x, y points exchange, that means if we plug b into the inverse function, we get a. So it's basically what I had written on the previous page, just kind of in a different way. Okay, horizontal line test. We've learned about the vertical line test before. The horizontal line test is what tells us whether a function has an inverse or not. Okay, so the horizontal line test can be used to determine whether the inverse is also a function. Okay, so okay, so let me show you what I mean. So let's start with just like a really simple parabola like this. Looks like that. And if we take the inverse, we're rotating it. And so what it ends up looking like is this. The inverse rotates 90 degrees and it looks like that. And what they're always doing actually is they're rotating around this line right here. And you can see that with the rectangle. If we put this line kind of straight down the middle, they're rotating over that line. Goes from here, rotates over the line, starts out here, rotates over the line and ends here, or it could start here, rotate over the line and end here. So that's exactly what our parabola is doing. Starts right here, we rotate it over this line, and it ends up right here. So if you're looking at our original function, this is a function. It would pass the vertical line test, but if we tried to apply the vertical line test to our new function, this is not a function. The inverse is not a function, and that's because it failed the vertical line test. Well, if we looked at our original function, we could have seen that our original function wasn't going to pass the horizontal line test. Okay, so this function right here failed the horizontal line test. I'll abbreviate. So because this one failed the horizontal line test, when I rotated it, this one failed the vertical line test. Okay, so since this one fails the horizontal line test, that means my inverse is not a function. If a function passes the horizontal line test, that means the inverse would also be a function. All right, so last thing I want to do on this video is find actual inverse functions. And what we do is we exchange the domain and range. Okay, so this one we don't have an individual set of x and y values, so we're literally going to swap x and y, rewrite the function. Okay, so first of all, this function, whenever I see an f of x, I can always write it as a y. Okay, so we can rewrite it like that if that's going to help you out. So like I said, on the fronts, on these ordered pairs, we literally took this x and this y and swapped them. This x and this y and swapped them, etc. So what we're going to do in the equation is literally swap the x and the y. So when we go to solve our inverse function, we start by exchanging x and y. Okay, so exchanging x and y is the first step in finding an inverse. So instead of y here, I'm going to write x, negative 1/2, and instead of x, I'll write y. And then what you do is whatever algebra you need to do to solve the equation for y. Okay, so we want to get it to a point where y is by itself again. So here we could subtract 1 from both sides. So we lose it over here. We've got x minus 1 equals negative 1/2 times y. All right, and then the next thing that we would do, we want to get rid of this negative 1/2. So we can multiply by negative 2. Because these things would actually cancel each other out. They would just multiply to 1. So I would do the same thing over here. Multiply both sides by negative 2. So I can distribute that negative 2. I will have negative 2x plus 2 equals y. So that's my inverse. The way I want to write it is with this notation. You write f inverse of x. So really similar to this notation, just throw in the little negative 1 for the inverse. Okay, so that's my inverse function. I'm going to sneak a little graph over here. So if I graph the original, this is in slope-intercept form, so my y-intercept is 1, so I can start there, and then my slope is negative 1/2. So I can go down 1, over to the right 2, and plot another point. And 2 lines or 2 points is enough just to get a general picture of what the graph is going to look like. So this is f. This is my original function right here. And then I can plot the inverse based on this. So plus 2, that means my y-intercept is 2. So I can start right there. And then my slope is a negative 2. So I can go down 2, over to the right 1. And then same thing, these 2 points right here. That's enough to show what my line is going to look like. Okay, so this right here is my inverse function. And you can see if we were to sketch this little dotted line in here, the black line and the red line are reflected over that line. Like this piece is reflected over here. This piece is reflected over here, all around that line. Okay, last one. Same thing. First of all, write this in terms of y, because I know the f of x is a little strange. First step is we literally exchange the x and y. So write an x here instead of a y, write a y here instead of an x, and then do whatever we need to do to solve for y. So the first thing we need to do is divide by 3. What I'm going to do is I'm going to multiply by 1/3 instead. Okay, so these will cancel out. 1/3 times 3 is just 1. So I will have a 1/3 x over here equals, and then I'll have a y squared. Okay, so last thing is I'm going to square root both sides here, because what will happen is the square and the square root will cancel out. So I'll have y by itself, and then I have the square root of 1/3 x. Okay, so rewrite f inverse, we're going to write it in that notation. This is the square root of 1/3 times x. All right, so that's what we're working with there. We're going to do a quick sketch. The parabolas we should know how to graph. This one goes right through the origin. There's no vertex change. And then remember the 3 means you can go up 3 units over to the right one. It'll make it narrow, and then we can mirror that point. So here's our original. We just practiced a couple chapters ago graphing those parabolas. And then we've got the square root functions. And the square root functions we just did. So that the 1/3 x means that we've got a nice stretch of 1/3. All right, so we can stretch it out that way. It'll make it kind of low to the x-axis like that. Okay, so that is our inverse function. Again, you can see the reflection over this line. You can see this piece gets reflected here.